Yes, it is good to be back on the screen. So today we want to look at pointers and dynamic memory allocation. We are still on pointers, so we need to conclude pointers. So what I want to show you now is the importance of pointers on dynamic memory allocation. You know, if you declare an array like this, int a, this is fixed. Now, this is allocated at the stack memory. So you have, assuming this is the memory, right? Let's just say we are dividing it into two, but it's actually into four. You can have this. So this side is maybe text, the code segment, then we have the heap, and then we have the stack. Now, this stack part of the memory is for what? Is for local and function calls. Now, if you want to dynamically allocate memory to anything, that would be at the heap. While this text and code are for read only, we're still going to look at this when we get to string. Now, memory allocated at this stack is what? At compile time. Compile time, like this one. What if I want to allocate memory at runtime? You say, God breathed into man, and man became a living soul. That means man can grow. So I want to allocate memory at runtime, and the only way I can access such memory is through what? Pointers. So a pointer is the gatekeeper of what? Dynamic memory allocation. So that is what I want to show you in this class. So let's write a program to demonstrate that. Let's say I say int include stdio.h. Then I'm also going to bring in another library, a toolbox, include stdlib.h. Now, why am I bringing this in? Because I'm going to call certain functions, which is what? Memory allocation, Malloc. Malloc function. That is memory allocation. Memory allocation function. So this function can be gotten from here. So it's the tool that you get from this toolbox. So I'll say int my main, right? Then I want to declare an array, but I'm going to declare a pointer, and this pointer will point to a memory that is allocated at runtime. So I will say int. So this is my pointer. I will call it array, ARR, and then I will assign this. Now, this malloc function always return a void data type. So because I am using it in the integer realm, I have to typecast it. So I'll say int. So this is typecasting. I'll call the malloc function, right? Now, this malloc function is expecting a parameter. So I'm going to say 5 multiplied by size of integer. So this is me dynamically creating a memory. So I'm calling this malloc function to create a memory. Size of integer is 4. 4 multiplied by 5. So that will be 20 bytes. So meaning I'm allocating 20 bytes for integers, but this is at runtime. Nothing will be allocated yet. Just like creating the womb, expecting a baby, right? So, but this malloc function does not initialize that memory size is going to allocate. So I'm going to have garbage values in them, random values, which I can access. So that is what I'm doing. So I'm calling this malloc function to create 20 bytes for 5 integers. Each integer will be what? 4 bytes. So for 5 integers, that's what I've done. Now the next thing I will do is I will have to test, because this is dynamically created. I will have to test to know if that memory has actually been created before trying to assign values to it. So the next thing I will do is I will call my if statement. If this array equals to null, right? Then go in and print out printf memory allocation failed, right? Return 1. Then close this. So I have done that because I dynamically created space in the memory. So this malloc is creating the memory in the heap. So this is like saying that um, you have the spirit, then you have the soul, right? And then this one will give you access to the heart. Guide your heart, for it is the wellspring of life. Now, whatever is in this spirit is read only. Read only. You cannot modify it. In order to modify what is here, you have to copy it into the heart using the soul. So this soul becomes a pointer to the heart. So without this soul, you cannot access the heart. Guide your heart, for it is the wellspring of life. Meaning, if anybody gains access to your heart, that means they've taken control of your soul. So whatever is here has to be copied here. So the logos, I'm still going to show you this when I'm teaching you string. Whatever is here has to be copied into this place before it can now be modified, right? So the soul is a pointer to the heart. Now, same thing is happening here. So I have created memory, a space in the memory at runtime, which is in the heap. And the only gatekeeper to that space is what? This pointer. So I am using this to check if that memory was actually allocated. If array is equals to null, it means the memory was not allocated. It was not successful. So it will come in and print out memory allocation failed. And it will return 1 as an error message. It will return error message. That is why we are returning 1. Now, if it was successful, then I'll be able to access it. So I will use a for loop to access the memory, because I've created memory for what? 5 integers. So to access it, I will say for int I equals to 0, initializing it, I less than 5, right? Because it's starting from 0. So it will be what? 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. So that is why it is I less than 5. Now, I plus plus, then you go in. So I want to print out the values that are in this memory. So printf array %d, then %d. So expecting 2 values. So for this one, it will be what? I. And then for this one, it will be what? A, R, R, I. Then close this. All right. So I'm going to close my for loop. Now, because I use malloc, I have to free it when I'm done, when I'm no longer in need of that memory space. I will have to free it. Else, I will run out of memory space and I will not be able to copy anything again. You know, I told you, I demonstrated something about spirit, right? Soul, and then heart. So dynamically, I'm creating space here. Now, if I am done with whatever it is that was kept in this place and I don't free this heart, it will become full. And next time when I need space again and I need to copy anything from the spirit into the heart, I will not be able to. So then you become depressed. So to achieve that, here, in order to free the memory that was allocated with this malloc, you have to call the free function. So I'll say free array, right? Then I'll say return 0. So I will close this. So in this case, what is this free function? That is what you call forgiveness. Forgiveness. So forgiveness is not actually for the other person, but for you. It is a tool you use in clearing up what you copied from this place into the heart. And if you don't copy from the spirit, you can copy from the flesh into the heart. Emotions, true emotions. So if you don't free up the space in the heart, it will become full and you will not have any space again. So forgiveness is the tool you use in cleaning up space in the heart once you are done with that process. So in programming, it is called free function, which you use in freeing up the space that Malloc dynamically created. So otherwise, your memory will be full and then you will not have space again to perform other tasks. So you must always call this function, right, to free up space in the memory. I'm still going to teach you malloc, calloc, realloc, and free function in memory. So this is our program. Now, when I run this program, I'm going to access 5 random values. When I run it again, it will keep giving me 5 random values because malloc does not automatically initialize the memory. So when you create a landmass, allocate the land for a particular project, you have bush there, right? So that is what is happening in the case of malloc. But in the case of calloc, it will initialize it to what? To 0. That I'm still going to teach you. So I have used malloc to dynamically create space in the memory, and then I've tested to know if it was created. If it was not, it will show me this, to print out this on the screen. But if it was, then it will come here, and I'll use this for loop to access the values that are inside. You already understand for loop. I've taught you for loop extensively. So you initialize I. For I is equals to 0, you come in, you test I is less than 5, that is true. Then you come in here, ARR, that is ARR 0. This will print out ARR 0, right? Then whatever is there, it will give you a random value. Then it will do ARR 1, it will give you another random value. Now, if I want to initialize this, I can use this for loop again to initialize and then use for loop again to access. When I go to code blocks, I'm going to demonstrate that for you to see so that this class will not be too long. So that is what I want to show you in this class, just to show you the importance of pointers to that in the dynamic memory allocation. That without pointers, you cannot access memory that was allocated at runtime. It is very important, meaning without the soul, you cannot access the heart. So let's go to code blocks. Let me demonstrate this for you to see. All right, so this is our code blocks on dynamic memory, pointers and dynamic memory allocation. So this is the script that I've written. Like I told you, I said I was going to initialize the malloc and then print out the values again. So if you look at this, this is us declaring dynamic memory and testing to see if it was created. And then using this for loop, we access the value, which is going to give you random values. Then I use this other for loop to initialize it by I becomes 0, 0 plus 1 becomes 1, 1 times 10 is 10, assign it to the first array, then increment I becomes 1, so 1 plus 1 becomes 2, 2 times 10 is 20, so you are going to assign 10, 20, 30, 40, 50 to those values. Then I use this other for loop again to try to access it. So you're not going to see. Then I freed the array. So let's run this script for you to see what the output will be. So you see, the first one, which was this first for loop, you can see this first for loop, you access it, it's giving you random values, and then you initialize it here using this for loop to initialize, and then you use this other for loop again to try to access it. So it's now giving you 10, 20, 30, 40, 50. So initially, Malloc does not initialize. So that's why it's giving you these random values. So that is what I want to show you in this class. So till we see in the next class, bye-bye.